Next time before come to class, read the material before come into class. Always do revision before come to our class. Okay. Last lecture, we stop at example 5. Today we learn about power, right? So recap, chapter 3. We learn about work. Work is force and displacement. You get positive, the vector of your force and vector of your displacement, they are same direction. If negative, means one of it is opposite of each other. Then you learn about principle of work and energy. Mean this one, the question asks focus on work and energy only. So in this case, we only look at kinetic energy. We will give you half mv squared, or we use T as our equation. So it will give you work on the left-hand side, energy on the right-hand side. So there's a change of work will equal to energy 2 minus energy 1, or in this case, we look at kinetic energy 1 minus 2 minus kinetic energy 1. You rearrange this one. This is called principal work of energy, or you can write in the positive form, T1 plus change of work equal to energy at your end station or station 2. This is called principal work and energy. And the benefit of using principal work and energy is that you can find your V very fast. Next, we learn about power. What is power? Power, you take your work, you do time differentiate, you get power. What is the unit of work? Joule over Joule. Joule. Okay. T is second, so power is Joule over second. So we look at power. Power is P equal to work divided by time, or not divided, time integral with your work. So earlier, we can define our work equal to force dot product of your position, dr. So you rewrite the equation, power equal to force dot dr divided by dt, or dt. Force, we pull out, dr dt, what do you get? Position divided by time, what do you get? Velocity. So you get force multiplied by velocity. So power, you have two definitions. One is the change of your work, the rate of your work. Rate means divided by time, or force and velocity. Okay, so again, you are dealing with vector now, dot product, force and velocity. So power, we use watt or joule per second or Newton meter per second. So you start to look into watt unit. Okay, any questions so far? Make sense? All right. So when you do a lot of power, and this one apply to all the engineering module, if you look about power, you deal with efficiency. Efficiency means how good is your system. Efficiency, we always take output divided by input. So in this case, you can take your power, you can take your output output parameter, mass flow, electricity, voltage. All this you can put in efficiency. But in this module, in this chapter 3, we take power of your output divided by power of your input. Okay. So this is how you find your efficiency. So let's say you have efficiency 80%. What does it mean? If you give 100 watt, what do you get as your output if your efficiency 80%? 80 watt, right? Okay, how you calculate efficiency again? Power output divided by power input. So output 80, input 100, so you get 0.8% or 0.8 ratio. You can put in percentage, means times 100%. Huh? Okay, this one is very direct. Huh? It can be power or can be any energy. Okay. Energy, we deal with two types of energy, potential and kinetic. Same. Huh? So let's look at this example 6. Example 6, the worker pushing this box here, and the force is 150 Newton with an angle. You are given a trigonometry relationship 345. The man pushed 50 kilogram crane with the force 150 Newton. Determine the power supplied by the man when the time is 4 seconds. Coefficient friction was given. It gives you crane start at rest. So here, he asks you to find power. What is power again? Definition of power is work divided by time. How you find work? Force is given. What is the direction? Distance. How you find distance? How you find distance? (150). Think. This is the way you start to think. Think what you learn in your chapter 2. What formula you learn in chapter 2? What is A? What is the definition of A? D V over dt. How to get S? Okay. Either you can ds square dt. What happens if you have a constant acceleration? What formula you can use? Huh? We have 3 motion equation, right? You want to find S, what equation you use? You have V equal to V naught plus AT. Does it give you S? Delta S equal to S prime minus S equal UT plus half AT square. Another one, V square equal to UT, no, U square plus 2A delta S. Which one is more suitable? Huh? First one give you what? V. You want to find what? So which one? This one or this one also can. Yeah, you have time. But the third one is more suitable because you don't want to confuse yourself with time. You need interest in and velocity and early velocity. Acceleration you can find, right? You know how to convert this diagram into free body diagram and kinetic diagram, right? So before you do, what is the free body diagram you have? Equal kinetic diagram. What is the two force? Normally you start. First one, weight go down. Another one, normal. And then what else? In this case, what else? Friction, what direction? To right or left? Left, huh? Force at a certain degree. A, this direction. V, also that direction. So F equal to MA in two directions, X and Y. Fx, Fy equal to MA. Solve for X, solve for Y. You have your AX, you have your AY. Find the resultant. A equal to AX square plus AY square, square root. How to find angle? Tangent. Find it different. Which one to which one lah. Okay. Get the idea. Don't chase after the numbers. You look at the question, try to think, what do you know? Then you start to develop the ideas, right? So you start with free body diagram and equation of motion. So you have weight, Newton, friction, and force. And then you have the kinetic diagram to the right, right? You have this one. So you solve for F equal to ma in the y direction or x direction. In this case, we start with y direction. So what are the forces you have in y direction? Which one? P times 3/5, positive, negative, negative. Then what else? Plus N minus W. Does friction need to add in for Y? Oh, huh? Okay. So you have Fx, Fy. Fy is what you say just now, huh? Okay. What about X? F then times Y negative, positive, force times 4/5. Then negative friction equal 0. Why 0? Nickel, why 0? Why AX 0? AX 0 or AY 0? In this case, look at the kinetic diagram. AX 0 or AY 0? Nickel. Huh? AY 0, why? Why? What is the reason why? Why AY 0? Explain to Nickel why AY 0? Because in your kinetic diagram, what is the direction of your A? X direction. When you have X direction, so you don't have Y direction, right? Yeah. So the first one is 0. Okay, Nicole, huh? I will ask you again for this one. Right, do the same for x. This one got value, right? So first one, you arrive at, you can find your normal force. Once you find normal force, you can find your friction force, right? So here, you can substitute inside here, right? So you have your AX from this equation. Make sense to you? Okay. Remember the unit, huh? Normal is the force, so Newton. Acceleration is the meter over second square. Right. Any questions so far? Once you have your A, you're given time. So you can either use the first one or the other second also can. But I show you the first equation first. V equal to V naught plus ACT. Why you can use this one? When you have constant acceleration. So in this case, you know your initial velocity is 0 because it starts from rest. AC you find just now, and T is 4. So you find your velocity. Right? What is the definition of power? Power equal to work divided by time, or force multiplied by velocity. So now you have velocity, you have force. What is the answer for power? $150. How you find 150? This one had 150. Why 445? Uh-huh. Why you take that direction? Why you take your force in that direction? Right? You take this direction, right? Why? Why this direction and not this direction? Why? Okay. Yeah. Correct. The keyword is parallel because you're dealing with vector. Power equal to vector force multiplied by vector V. It must be parallel. So if the direction is same, then you give positive power. Okay, so in this case, they are same direction. Give you. So what is the answer? Can you press calculator? Verify the answer. What is the power for this example 6? Hmm? 27.4. What is the unit? And power. What is the unit of power? Joule over second or watt or Newton meter over second. Correct. Okay. So the answer is 37.4 watt. Okay. Example 7. Still applying what you learned. What is the definition of power again? Power equal to force multiplied by velocity. Or you take work, differentiate with time. Okay, you are given a motor. You want to, this motor M here, you want to lift this object C. The mass is given, mass C is 35 kilogram. The acceleration at point P was given. typo error there. It should be 1.2 meter over second square. Typo error in the question. Because it's give you acceleration. You're given acceleration of p here. Determine the power must be supplied to the motor at the instant p has velocity 0.6 meter per second. Ignore all the mass. The acceleration of p is what? 1.2 y minus 1. Y minus 1. What is the acceleration? What is the velocity? What is t? So, what is the final? One minus one just now. Just now you say acceleration is ms. There's a typo error here. I mentioned already. There's a typo error here. Okay. Moto M. You're given what? The arrow of A is pointing to the left, right. Why? Why to the right? Why I say to the right? Because arrow was given. A is what? 1.2 meter over second square. Velocity also given 0.6 m stroke s. This is a pulley system. Right? Pulley system, first thing you look at the datum. Datum C go down positive. Datum for P to the right positive. Previous example, when you look at pulley, both all vertical or both horizontal. This one, you have one horizontal, one vertical. But anyway, just focus on the steps that you learn in your pulley system. You look at the pulley system. First, you look at the datum. Second, you look at the total length. What is the total length? SC, 2SC plus SP. Then, what's the next step after you find total length? You differentiate with time, you get what? Velocity. You differentiate one more time, what you get? Acceleration, right? So that is the pulley system. Every time you see pulley system, remember the datum first. Where is the positive, where is the negative? Then you find total length, differentiate, get V, differentiate, that get acceleration. What is the purpose of calculating the V and A? To find the relationship between two objects. In this case, if C hoist lift right? So C go up, right? If C go up, what happened to your P? C go up, P to the right positive. So both give you, no. So C negative, P positive, right? Right. General assumption must be logic. Then you do calculation. Okay, then it tell you the efficiency. Again, what is efficiency, Nico? Okay, energy output divided by energy input, or power output divided by power input. What is the power definition? Okay, efficiency equal to power out, power in, right? What's the definition of power? F dot V, F dot V. All these are output, output input. Okay, let's solve. Free body diagram again. You have two cable here to the C, but only one cable to the M. Two tension to C and to P. What is the tension value for cable here, Nico? How you calculate? You have two cable, right? So you have T, T. Then what else? So what is the value of T? Huh? How you calculate tension cable? What is the value of W? Time. Time what? Okay. So what is T? You learn static, right? How to do equilibrium diagram?
T minus 2T minus
Minus equal. So what is your T? My answer is, what is your T? Calculate, calculate. Press calculator. What's the answer?
0.67.
171.6. Okay, Newton. Okay. So you find the tension cable to the west here. Can you see? This tension cable, what? But this tension cable go this way. So you have the force go inside the motor. What is power again? Power equal to force times distance. Right. You have force already. Where do you find the force? Huh? Sorry. Huh? There are two definitions of power. Power equal to work divided by time. And also force and velocity. So you have the force already, right? You are given velocity, right? Can you find power? Yes, right. Only differences is you don't know how to whether you know how to balance the force. This is two cable. Right, free body diagram. You draw crane C, W, and 2T pull up. So you find the T, and I overlap the kinetic diagram. AC go down, Y go down. I follow the datum direction. So F equal to MA, go down. W equal to 2T equal to MAC. So I have this one equal to MAY, first equation. Again, the next one, we want to link C and M. Use the pulley equation. All right. So pulley equation, L equal to 2FC plus SP. Differentiate this one 0 equal to 2VC plus VP. Differentiate one more time, you get A. 0 equal to 2AC plus AP. Makes sense? So AC equal to half minus half AP. Minus means opposite direction or it slow down, right? Yeah, 2. So you have the acceleration at P, you are given in the question, 1.2. So you have minus 0.6, substitute back here, you get your T, right? Yeah. So, okay, previously, the equation here, what is missing? What's missing? This one, you're using equilibrium of force. You need to consider acceleration, F equal to ma. Here, you equal to 0. The previous one, you get T equal to 171, is you assume 0. But the acceleration here is not 0. Okay, acceleration here is getting faster and faster. So acceleration is not constant. No, velocity is not constant. Okay, so take note. In engine dynamics, it's very rare you use static equilibrium equation. Static, yes. When it comes to engine dynamics, you need to consider the motion on the right hand side. Okay, so the answer is not 171.6 Newton. The answer is 182.2 by considering MA on the right hand side. Okay, take note. This is the careless mistakes. Okay, so once you have A and T, go inside the power definition, power equal to F multiplied by velocity. So in this case, the force is the tension. You put inside there, you get 109 watt. Okay, so 109 watt is what? This is the energy what? Input or output? Output. This is the one that energy that you or power that you need to use to lift this one. The question asks you the power that must be supplied. So it asks you the input power. So call out the definition of efficiency, output divided by input. Rearrange the equation. You're given the efficiency. Pull to the bottom. Pull the input to the left. You get this equation. Substitute, you get the answer. Okay, the answer is 129 watt. Makes sense. Okay. Huh? This is input. Oh, sorry, this is output. What I mean by output is what you get. Output is what you need. This is the customer. This is from the factory. So you take output. Output means what do you get? Right? What do you get? I mean, what do you get in the system? So this is the 109 is the one that you need to lift this one, right? But the question asks you need to supply because there is a 85% efficiency. So you need to supply more, right? Your power need to supply more. So input is the one that you need to find. Okay, efficiency never more than 1. Maximum is 1, but rarely get 1%. Rarely get 100%. Okay, there's a friction, there is a loss of energy, and so on. Right? Okay. We go a few more slides, then we stop. No class right after this. All right. So we go into conservation of force and potential energy. Now, we'll introduce you, before this, we work principle of work and energy. Today, we introduce you conservation of force and energy and potential energy. All right. Now, conservation of force, what mean by conservation of force? If the work of the force is independent of the path, mean we no longer see position, no longer see how it moves depend on the force initial and final position. Mean we only look at force only. Then we classify force as conservative force. Two type of example. For example, W. W is conservative force because it doesn't it's only rely on vertical placement of weight, right? And the force developed by spring, if you see spring, it only go up and down. Okay, so there are these two type of force. So work done by the spring depend only on the spring elongation and compression. Work done by the weight is depending on the displacement of weight. So it doesn't dependent on the path. Okay, here the conservation of force is only look at the position and not path. What is a non-conservative force? Friction. What happens if you leave this object at a certain degree and it slide down? The more you travel, the more work is done by the friction force. If you travel more work done means it's not conservative. Weight just now is only up and down. So once you move up or move down, you conserve the energy or conserve the work. Spring also same. You either press, it will go back. Press, it will go back. It conserve the work done. What is work? Work is force and displacement. Okay. So again, force, you have conservative and non-conservative. I give you two examples just now. Spring and weight, they are conservative. Friction force is non-conservative. Example, conservative of force and potential energy. Why potential energy they are conservative? Let's look at this example. We start to introduce you potential energy. Potential energy, we use capital V or potential energy. Remember, you always focus on datum. You know that PE equal to mgh. You have positive value and negative value. How we know positive value, negative? Depending on datum. If the object start from position above datum, you get positive potential energy. Why? Because the H is positive. Datum, above datum, you get positive Y or positive H. If the initial object position is below datum, you get negative mgh because the H is below datum. You get negative Y. So you get negative potential energy. If the object start at the datum, what is the potential energy? 0. Why 0? Because the H is 0. So start from today, look at the datum. It's not necessary your potential energy always positive. In your previous class, physics class, your potential energy always positive. But when it comes to engine dynamics, look at the datum, starting location, where is it? Does it above or does it below or it at the datum? Okay, let's prove. Does the energy conservative or not? What's the equation of potential energy? mgh. Right, so if above, you get mgh or wy. Same, okay, so elastic energy for spring. What's the equation for elastic energy? Half kx squared. This is a spring energy equation. What's the spring force? F spring equal kx. There's a difference, energy and force, don't confuse. So you look at the spring, where's the datum? Unstretched. When you unstretched, mean no energy, right? You don't load the spring. But if you pull the spring, the S is positive, right? Because this datum to the left, positive. You get positive S squared, you get positive energy. What happens if you compress? Negative S, right? But how you calculate energy? Half K S square. When you square, what will happen to your minus? Positive. So for the spring, you always get positive energy. Only for datum that deal with H, mgh, you need to be careful on the datum. Above datum, positive. Below datum, negative. For spring, always positive. Okay, always positive. Potential function. Let's say we have this two. So total energy. If you have potential energy, then you have under gravitational force. Then you have mgh plus elastic energy if you have spring. If the question have position, change of position, and the spring, you need to use this equation to calculate potential energy. Makes sense? Yeah. So work done by conservative force in a moving particles from one point to another one is measured by difference of this function. This is what? U is what? Work. What is V? Potential energy. What is mean by principal work and energy? In this case, if it's under conservative, all the work will equal to all the potential energy. So if you have a spring combined with the object, spring and object, so you need to consider two potential energy. One is due to gravitational, one is due to the spring. Gravitational, you need to be careful on the datum. In this case, it is below or above. Below datum, so you'll get a negative energy, potential energy for this case. So spring, no matter it's pressed or elongate, you get positive energy. Let's calculate. So in this case, you have a negative mgh or minus s plus half ks squared. Right. So if the particle move from S1 to a lower S2, so means you move from lower, your energy 1 minus energy 2. You take potential energy of 1 to 2. Why 1 minus 2? From this one to another one. You get this equation. V1, you have two energy, potential plus elastic for the first one, first position, minus second position. Okay, so you arrive at, this is just a rearrangement. Important is this last two equation here. Makes sense? Okay. So let's say you have two particles, this is a derivation. This object move from bottom to top with the dy, dx, dx, dy, dz. Okay. So this is just derivation. Is not very important for diploma. But what is important is that work, definition of work, you can break into x direction, y direction, z direction. Still the same. Force in x multiplied by x plus y work plus z work. Okay. This slides is to tell you that if you go into degree later, there's one symbol called inverted triangular here. It's called vector operation. Right. I think you see this one in your partial differential in your max 2 or max 3. I'm not sure which one, but you will learn about partial differential. You learned partial differential before, right? No, I haven't. Okay. You might learn this one in your max 2 or max 3. Okay. There are many max 3. All right. So when you go into max 3, you will see this one. Partial differential. You will see the question give in vector operator. You see this one means you convert this one into this form. Okay. But for this module, I won't ask you this one because you haven't learned, right? So if we combine all we learned so far, we have kinetic and potential. We combine the principle of work and energy. Kinetic before plus potential before plus non-conservative work equal to energy, kinetic energy at station 2 plus potential energy at kinetic at station 2. Makes sense? This one normally come into final exam. So you need to consider kinetic, potential, and work in your solution. Normally this one is the first section A. Then section B will ask you consider conservation of force in your solution for B. What I mean by conservation force only in your calculation means you cancel the work done in the non-conservative. Means energy before equal to energy after. You consider potential and kinetic, right? Kinetic and potential before equal to after. This equation is called conservative of force. Normally it comes to section B of the question. This is section A. You do calculation, you find missing parameter, velocity or acceleration, and so on. Then section B, you ask you, same setting, but now consider only conservation of force in the solution. You rewrite the equation, cancel the non-conservative, you write this one. Find what is the difference between A and B. A will give you slower velocity, B will give you faster velocity. Okay. In your physics, you proved this one before. If you pull a basketball to the maximum position, you have kinetic energy equals 0 before you drop the ball. Maximum potential energy with positive. Why positive potential energy here? Because datum at below, you are above datum. At the middle, you have half potential energy and half kinetic energy. At the bottom, your potential energy 0. Why? Your H 0. Your kinetic become maximum. Why? Because before it touched the floor, velocity maximum. Okay, so the proof of conservative energy using T1 plus V1 equal to T2 plus V2 prove this. Okay, you always get WH. Here you get WH. Here you get half T1, half V1. Combine, you will get WH. Here, same, you get WH. So at 2, how you prove the velocity? Velocity at 2 is h divided by 2. You get your v equal to square root gh. You substitute into the equation. E equal to T2 plus V2. T is kinetic, V is potential. So half mv squared, your V is this one. You do calculation, you still get WH. Same with the last one, you still get WH. Okay. So there's no change of energy if you use conservative of energy. Okay. In this case, when there is no air resistance mentioned in the question, there's no F drag force here. Okay. So if you are given a group of tension, a group of particles, then you combine. You just write a sum symbol in front of the energy. Okay. See now. Okay, let's go into this example. Okay, okay. So if you look at this photo, there is a body hanging on the testing rig here. So when you cut this rope, this object will swing down. So it tells you that this object was given a 20-meter rope tied to the body. So the plane having a mass of 8 megagram, you need to change to kilogram. Hoist back until theta 60 here, 60. Then the pullback cable AC release when the plane is at rest. So here V early 0. Determine the speed of the plane just before it crashed at B. When the angle here is 15. Also, what is the maximum tension developed in the support cable during the motion, which is here. Ignore the size and the effect of lift caused by the wing during motion. You look at this question. What motion you have? Rectilinear or curvilinear? Why curvilinear? Why curvilinear? Huh? Yeah, because you have a constant R there. And you cut cable AC, this one move in a curvature motion. So curvature motion, what do you bring? First, you always draw free body diagram. Once a free body diagram, you have curvature motion, what do you put inside? Tangent and normal. Tangent normal, let's say this object, tangent normal. What's the next steps? Recall A, you have normal direction and tangent direction. What's the equation for acceleration in normal? Huh? Normal. Tangent is Vt, what? Vt is V dot lah. This is the Vt over dt. Normal. V square rho. Okay. Normal always deal with rho 1. So remember this way. Okay. So you look at the photo, you look at question, and basically you know what to do already. Basically, even though before you read the question, you look at the question, you look at the motion, you know that fall under what chapter already. I mean, what step you need. In this case, there's a collinear motion. So when you draw free body diagram, first step also free body diagram. Then free body diagram, you have now learned one more, which is kinetic diagram. So yeah, so before you start, you have free body diagram, kinetic diagram, break into two, or you can combine two. So free body diagram, kinetic diagram give what? Chapter 2 equation. All the force equal ma. Then collinear motion, you have normal and tangent. Break this one into all the force in tangent equal to m tangent and normal. Again, you can calculate this one, right? This one. Where you get the force? From free body diagram. This one from your free body diagram. Let's draw free body diagram at point A. How to draw? How to draw? Like that. Tangent normal. Then, what do you include, Nico? Wait, well, become expert already, Nico. Wait, point down. Then, what else? Normal what? Normal what? No, you already draw what? What else? The next step. What else? What else happened to the body? It tell you to find what? Tension. What? Where is tension? Where should you draw? Where should you draw? Here? Here? You look at the scenario here. Where's the cable? How the cable tie? How the cable tie? You imagine you are the plane. How the plane tie to your body? You imagine you are the plane. You are looking down, right? So there's something at your back, right? So how you draw the tension? Pulling to the normal direction. Makes sense. What pulling to the normal? What's the direction of normal? Always pointing to the inside of the curve. Makes sense. Okay, so you have two forces. Then, what's the angle? 15. This before the crash lah. Why you focus on 15? Because it tell you focus on 15 before it crash. So there is a diagram difference between A and B. So focus on what the question want you to find. The force is different between A and B. Okay, in this case, we use conservation of energy for this example. This question can solve using equation of principle and work on energy. But in this case, we use conservation of energy. The question will tell you directly whether you need to use which equation. In this case, use conservation of energy. Conservation of energy, you only focus on energy only. So what? Only two types of energy you learn in this module, potential and kinetic. So potential kinetic left hand side equal to right hand side. So what is the equation for kinetic energy at A? Half mv square A. What is the velocity for A? What is the velocity at A? Y0? Rest. So you can cancel the first one. But you still need to write half mv A square. What is the potential energy at A? You look at the datum. Where is the datum? Where's the datum? Here. What is your H? Go down, Okay. Minus. Because datum is on top of the plane. The plane is below datum, so negative. HA from the datum equal to half mv b square. Again, minus WHB because still under the datum. Any questions so far for this one? Then you substitute all the answer, you find your VB. Okay. VB square, you have two answer, positive, negative. choose the positive. Then use equation of motion because you need to find the tension. Just now you haven't find tension. Go back to the free body diagram. F equal to ma. Huh? Don't use all the force equals 0. Huh? The one is in static. In dynamic, you need to equal to ma. Okay. So normal force, acceleration, mv square by rho. In this case, rho is given 20. If not given, you need to calculate equal to 1 plus something divided by something. In this case, you substitute, you find the tension. Makes sense. Okay. Here, example 9 is about spring. This one as a homework, you go home and read. Basically, what does this system do? This will go down, hit the spring. This spring, you have two springs, one spring outside, one spring inside. So the question will ask you, determine the maximum displacement of A, need to stop the downward motion of the ram. The unstretched length of each spring is indicated in the figure. Ignore mass of the spring. You need to find the maximum displacement of A here. Go home and read this example. Okay, all the answer is there. If you have any question, ask me. Okay, ask me. Yeah, okay. All right. With this, we conclude chapter 3. Okay, all the answer is there. Huh? Okay. Okay, we dismiss here.